Welcome back. Today we shall discuss few questions based on our earlier understanding of the concepts of mechanics and Newton's laws of motion. So let's quickly move to those elementary questions. So the first question: when a string barely strong enough lifts a heavy weight, it can lift the weight by a steady pull, but if you jerk the string it will break. Explain in terms of Newton's laws of motion. So we all know there is a heavy weight M. If you try to pull it quickly, the string snaps. So how do you explain this? So let's see the forces, analyze the forces that are acting on the body. So for this mass M, you have the weight, which is mg, acting on the mass, and the tension T, which is provided by the string when you pull it on an upward direction. Now due to your pull, or the force T which acts on the mass M on the upward direction, it will have an acceleration A, let's assume. So the same equation which we can write is T equal to M into G plus A. So from this equation you can see that the tension is dependent upon this acceleration A. So if you have provide a higher acceleration to this heavy mass, the tension will increase, and as a result the string will snap. So if you pull the mass with a very low acceleration or very slowly, that implies that this acceleration is very low. As a result, the tension is almost equivalent to mg. It can never be less than mg. So as a result the string doesn't snap, but a quick pull will snap the string. So the next question: Newton's first law and second law are equivalent. Please explain. And this is a pretty simple one. As you know, Newton's first law basically gives the definition of force, whereas the second law basically tells how do you measure the force. So let's see from the Newton's second law. We have force equal to mass into acceleration, and if no force acts, let's assume when no force acts, then since mass cannot be zero, acceleration on that body is zero. Acceleration zero means that the body is continuing with the same velocity, or if it is at rest, it's continuing in rest. So basically when no force acts, either the body is at rest, or if it was in motion, it continues in motion. So this is precisely what Newton's first law states. So let's move to another question. So this is more than concept, it is on the language of definition of force. So we define a force as a physical quantity which when acts on a body produces acceleration. So the question is, when you pull a heavy block, it doesn't move in spite you apply a force. So as per the definition, this force F when applied on this box should have caused an acceleration, and irrespective of its weight it should have moved. So what goes wrong is the definition, what goes wrong with the definition of force. So let's see. So when you apply the force F on this heavy mass, there are other forces also which comes into play. You have the reaction and the weight and the reaction being the same cancels out, and you have the frictional force, and this frictional force for heavy masses is large enough, so you cannot pull. So when you pull, the frictional force is large enough for heavy masses. That's why irrespective of you apply a force, it doesn't move. But then the definition wise, it says if a force, here this word is of very important. So if a force acts, that's if a single force acts on a body, it can never be in equilibrium. So had it been it on a frictionless surface, whether no frictional force, it would have definitely caused an acceleration. So if a single force acts on a mass, how heavy it is or how large it is, it will definitely cause acceleration. So there's nothing wrong with the definition of force. So let's move to the next question. So this is very simple one. I mean, most of you will be knowing this except those who have just learned the concepts of friction. So a body of weight 30 Newton is kept on a surface with coefficient of friction 0.5. What is the frictional force experienced by the mass when it is pulled by a force of 10 Newton? So here I have 30 Newton, a body with weight 30 Newton. So I pull it with 10 newtons. So what's the frictional force? The instant answer which I get is 30 into 0.5, that is 15 newton will be the frictional force. So if the frictional force is 15 newton and you pull it with a 10 newton, it should have moved towards the left instead of right. So what's wrong? So basically, as we know, friction, the answer lies, friction is a self-adjusting force. So it won't be 15 newton when you pull with a force of 10 newton. The answer will be, it will be 10 newton, because frictional force increases with the amount of force you apply till a point reaches, which is this point, that mu into r. At this point it keeps constant at 15 newton. So if you apply a force of 1 newton, the frictional force will be 1 newton, 2 newton, 2 newton, till the external force reaches 15 newton. So after 15 newton, if you, whatever force you apply, the frictional force is constant at 15 newton. So friction is a self-adjusting force, and this is the mu into r is the maximum frictional force. Hope I could clarify this. So let's move to the next question. It says a ball is thrown from the edge of a high cliff. No matter what the angle at which it is thrown, due to air resistance, the ball will eventually end up moving vertically downward. Justify this statement. So suppose we move to a very high cliff and we throw a ball. So when you throw a ball, basically you give a horizontal velocity, say Vx. So the moment the ball is thrown, it has only this horizontal component of velocity, which is Vx. But just after you release the ball, due to the gravitational pull, there will be a downward component of velocity too, which is Vy. So Vx is given by ux plus at. A is the acceleration. In this case there will be deceleration, because the air resistance will cause the ball to slow down, whereas Vy, that is the downward velocity, will keep on increasing due to g, the acceleration due to gravity, which is positive. So A being negative, a time will come when there will be no horizontal component of velocity, only there will be vertical component, and this vertical component of velocity will keep on increasing. So this is precisely the answer. So the next question is very simple one. Another again, a ball is thrown vertically upwards. At the extreme top, the point from where the ball starts the moving downwards, the velocity is 0, however it has an acceleration which is equal to g. How do you explain this? So when you throw a ball, what happens, you impart an initial velocity and it goes upward. While it goes upward, the gravitational pull keeps attracting the ball towards down, and so you have a downward acceleration. So the ball slowly slows down, and at one point of time, at this highest point, basically it changes its direction. So at this point the velocity will be 0, but you will still have the acceleration, which is due to the acceleration due to gravity, which will be constant in its entire journey. It will be g. So even though at this point the ball will have a velocity 0, it will have an constant acceleration. Basically the question is asked in a reverse manner. Give me a scenario where the velocity will be 0, however it will have an acceleration. So this is the scenario. Or even in simple harmonic motion, you can, at the extreme end, you will get this scenarios. So let's move to another question. It says, when a body moves in a curved path, how do you explain the existence of an acceleration which points inwards? So whenever a body moves in a curved path, there is always an acceleration which points inward towards the concave part of the curve. So how does that come into the picture? So let's assume a particle is moving in this curved path. At t1 instant, say the particle is here. At this instant, let us assume that the instant velocity is v1, which will be of course tangent to the curved path. At t2, the instant the particle moves here, then again you have velocity v2 which will be tangent to this part. So how do you explain acceleration? Acceleration is the rate of change of velocity. Here the change in velocity is also, since acceleration is a vector quantity, velocity is a vector quantity, the change is not only in the magnitude but there has also been a change in the direction. So the difference between the two vectors, you will get this. So delta v is your change in velocity, and the acceleration will point in the direction towards the change in velocity. So you will always have an acceleration E towards the concave or inside of the curve as shown in the figure. In case of circular motion, the magnitude will remain the constant. However, since the direction has changed, there will be an acceleration which we call the centripetal acceleration, and this will be exactly at 90 degrees to the instantaneous velocity. So this centripetal acceleration will cause change in direction but not change in magnitude. And since there is a acceleration towards the center, so you will have a force also too which will be directed towards the center. Hope you could understand why you always have an acceleration which is pointed towards the center when a body moves in a curved path. And now the last one is a simple problem which I leave it to you. You can solve this problem. If you are unable to solve this problem, you can always contact me. I will provide you the solution. Hope you have enjoyed this session. Thanks. Bye.